All right. We appreciate you taking the time to be here with us today. So, I have had the privilege of knowing our presenter since we completed the agroecological training of Integrity Soils Create program in 2022. She is a soil scientist and an educator with a real gift for helping farmers and ranchers improve and monitor their soil health, pasture, and crop quality. She's helped producers pursue their soil health goals through grant writing and hands-on practical guidance since 2016. She is also the founder of Red Dog Soils, a Denver, Colorado-based soil health and consulting business. And I really appreciate her generosity in sharing her case studies with us today. So without further ado, I am welcoming Rebecca Baldwin-Kordick to share with us.
Thank you so much, Rachel, for that lovely introduction. I'm just gonna get my screen shared up here. I'm really excited to have you all here today to listen to some of the work that I've been doing recently that I'm really excited about. It's always fun uh, to make recommendations, to work on the landscape with producers and get some results at the end. So always really excited to share what I'm finding. So I want to thank Boulder County Soil Health Initiative grant for funding this work that I did in partnership with my client, Grandma Grass and Livestock. And this is 3 trials to improve pasture. So a little bit about me. I think Rachel honestly covered most of it. Yeah, I'm based in Colorado. I work with farmers and ranchers to help them achieve their agronomic goals through the lens of soil health. And it is true that I like to do fun things on the weekends. This is a picture up here on top of, can you guys see my cursor? Yeah, okay. This is a Rio Grande cutthroat trout in southern Colorado, and that's a native trout and one of the most beautiful trouts, I think, and my favorite to catch. So, but without further ado, I'll get started. We have a lot of content to cover. I already talked about myself, and I will just touch on the state and importance of pasture lands in general. Then I'll get into some client context, and I'll talk about the site backgrounds that we're going to be talking about today, then the methods that we used on those sites before we get into some nice juicy results, and then we'll summarize it all at the end. So to start, about half of the the total land area on Earth is grasslands. And that comprises about 30% of the land area of the United States as well is also grassland. And that can be divided up into rangeland and pasture land. That's how the USDA designates pasture land in general. And so this map is from the USDA, and you can see this sort of tan colored um, area is rangeland, and this more green colored areas are pasture lands. And altogether, they make up these working lands that we use to provide vegetation for mostly for livestock. So these are working lands. And in 2024, Northern Illinois University published a report, and every week during the growing season, FSA agents and other extension personnel take stock of what is the quality of cropland, but also of pasture lands. And so they compiled that data from 1995 to 2022, and they found that our pasture lands, rangeland and pasture, is in decline in terms of its quality. And that is most extreme in the southwestern United States It is true, however, that some areas are improving, and most of that's in the eastern part of the United States. But as an average, our pasture lands are generally declining from the start of the season to the end of the season, and over this duration of time that they looked at. So it's important for us to pay attention to that. There's a lot of potential threats to our grassland systems, including development, land use conversion, climate change, especially, I think that's probably leading in some of these issues that we're having in terms of this quality diminishing in the West, Southwest, and overgrazing is a major one too. And when we think about grasslands, a lot of times we think of ecosystems. And in this particular area where I'm speaking about today, the typical ecosystem that was originally there is the small grass prairie or the sagebrush steppe. And this is such a lovely illustration that Audubon Rockies did. I approve of it. For many reasons, including that it also includes soil microbes as represented by all of these different flora and fauna that you might find in a sagebrush steppe. So I encourage you all to look at that. I'll have a link for it later that you guys can take a look at. But I love this illustration. I think it's really lovely. Thanks, Audubon Rockies, for doing that. And in addition to an ecosystem, there are many different benefits that grasslands provide to us in addition to just providing biodiversity, right? So a healthy grassland system begets a healthy soil, and a healthy soil begets a healthy grassland system. They go together hand in hand. And so when we're looking at these soil functions and these ecosystem services that soils provide, it's very similar to what we're considering when we're thinking about grasslands and what they provide to us too. First and foremost, I think that being provision of food and fiber, right? We're raising livestock in these types of lands. And then also carbon sequestration. FAO estimates that 1/3 of terrestrial carbon is stored in our grasslands, and it's a huge sink for more carbon storage too, if we can improve the quality of these grasslands. They also provide water purification services and nutrient cycling as well. We already talked about habitat for organisms. And flood regulation is a huge one as well. This particular area also that I'm talking about in Boulder County, and in Colorado in general and globally, we're seeing, so many climate extremes. In 2013, we had a 1,000-year rain event where we got our total annual rainfall in about 2 days. And, we're still there's parts of our grasslands that are still recovering from that, and other communities as well. But you can see why having a more resilient grassland and a more resilient ecosystem might help us take on more of that water. And then in addition, in 2020, we had 3 of our largest fires on record in Colorado. And, they were all in the same year, and one of them burned over 200,000 acres. And then in 2021, we had one of the most destructive fires on record. We had 1,000 structures that were burned in 2021. It was December 30th, so this was our winter. And it coincided with a very strong wind, like amongst the strongest winds that have been recorded, 112 miles per hour here. And it was a grassland fire. And it was fueled by so much vegetation that was oxidized and had not been utilized or incorporated and was not cycling effectively. So these are issues, in addition to droughts that we're experiencing this winter in the West, that are front of mind for folks like my client here, Grandma Grass and Livestock. This is their lovely team. Andy Brider is in the middle. He is the founder of Grandma Grass and Livestock. And I've worked with him mostly and also Emily Gallagher here most directly on this particular grant. And they, Grandma Grass and Livestock, their mission is to provide their community with healthy beef. And then also at the same time, improve the land upon which they are grazing. Um, that's their whole mission. And it is the truth that in Boulder County, land is hard to come by, it's expensive. And so they've really carved out their niche in utilizing public lands and like county lands and city lands and some private lands, um, but that generally are not productive for cultivation anymore. They used to be maybe at one time, and then they're just sort of derelict, and that's sort of what's left that nobody else is wanting to take on. And so that's what they're doing, and they're trying to improve these landscapes through their grazing. And so they have other grants too that they're trying to monitor this over time. But that in its core, is what they're trying to do on the landscape. And so they have a whole different, got a hodgepodge of different types of land that they encounter and need to be working with, and they wanted that represented in the types of lands that we were testing some of these methods upon. And in case I don't know who all's in the room, I can't really see everyone, but if folks aren't from the US or maybe just aren't familiar, Boulder County is right here in central and northern Colorado. And it's right at the base of the Rocky Mountains, right where they start. And so it's that transition zone between the prairie and the mountains. And so those three parcels of land that they wanted to focus on for this project, one was a private piece of private land, and here you can see we had a treatment and a control, and then another treatment and a control here is about 8 acres, and then these are not to scale. This is a 5 acre parcel. That is, they call it an island, and this is very close to their own headquarters, and they graze a lot of the lands around it very conveniently, but they use this road quite a bit for their own livestock purposes and moving water and that sort of thing. And so it's just not very convenient for them to be grazing on this island area. But it's very representative of an area that they do graze frequently. It's just a parcel of one that they don't. Um, and then this other site here is public land, and the whole thing's probably about 75 acres, but the treatment area is about 25 acres here, and then that control, which we'll talk about a little bit later, is over here. And then their goals as grandma grass and livestock were to first, increase forage productivity and quality, second, increase the plant diversity that's out there, and then third, improve the soil microbial activity and the levels that were out there. And so we'll talk a little bit more about each of those sites now with those goals in mind. So that first site, this is now looking on the ground and looking down at the ground too in a smaller picture. This first site, it's an irrigated piece of land. It's the only irrigated piece of land that we're talking about today. And then it's a private piece of land, so there's off-farm income, and that landowner is interested in having that land restored sooner rather than later. So they have a little bit of a potentially a larger budget to work with. And then they contract the grazing from grandma grass and livestock to come out on there. So livestock are around sometimes, but maybe not all of the time. And so we thought this was a good application for a biological stimulant product that was already in a jug, already ready to go, very, very low, um, effort needed to just get it out onto the landscape. And the other part about that is this particular product, which is it's an AEA product, Advancing Eco Agriculture product, that is typically used more often in cropping systems. This is also a little bit more akin to that because it's an irrigated piece of land. So we were curious about how this product, which is effective in some of those cropping lands, might be effective in this pasture context. And so the second site is unirrigated land. It's a former tree nursery, which essentially just means that these um, that there was a lot of vehicle traffic in this area previously, and and so it caused a lot of compaction. And so I'm not sure if you guys can see, but there are these lines that sort of extend out into the horizon. And those are remnants from this area being planted to native vegetation again. But this happened like 10 years ago. So these roots and these plants are not really able to get out of those planting lines, probably due to this compaction level that's out there. And again, there's not a lot of grazing infrastructure in this particular area, so it's not extremely convenient to get livestock in this particular area, but it's still, again, representative of where they do graze, which is surrounding this area. And so for this area, we wanted to use a high fungal compost because this land is under their management and they don't have as big of a budget. And this high fungal compost is a little bit less expensive. Well, quite a bit less expensive potentially. And so that's what we used here. And then the third site was also unirrigated. So this is unirrigated. I've got like a droplet with a line through it, no water. And this area had been historically hayed pretty extensively, and this is that public land. And there is grazing infrastructure, there's fencing all the way around, and so it is conducive to having livestock out there. And you can see that this land has a lot of oxidized or just dead organic matter that's out there sitting on the ground, and it's not cycling in the system. That's what's happening also out here with all of this brown material. Even the stuff that's on the soil, it's not cycling in the system. There's not a whole lot of bare ground out here. There is quite a bit of bare ground out here on this site. And on this site, you can see there is quite a bit of bare ground there as well. So for this third site, because it's more conducive to livestock, Grandma Grass predominantly does livestock activities on the landscape. They wanted to test out bale grazing and how that affected and how that compared to some of these other land application trials that we were doing in terms of improving these goals that we're keeping in mind. So we'll get into methods now. And so for that first trial method, we did a biological application in 2025, April 16th, and that we used a product called Rejuvenate. That's that AEA product that I was telling you about. It's full of carbohydrates. I can give you, I won't list it now, but you guys can ask about it later and I'll tell you after when we have time for questions. It's a lot to list off. And then we did a fish hydrolysate and a soil inoculant out there. And then we did a hard mow that was meant to prevent a lot of competition from the annuals that were out there so that this planting might have a better chance of getting established out there. And we just wanted to try to see if these really nice products could allow the seedlings to be healthy enough to really get a footing, and to maybe bypass some of the more extensive processes that are involved in reestablishing uh, pasture or reestablishing different species in pasture that includes tilling and growing annuals and then growing the natives that you're wanting to reestablish out there. So that was part of this trial as well. And then we did a micronutrient application that previous soil and plant tests indicated to me and I recommended for this trial. And then we did monitoring out in late July. And the second method, that high fungal compost extract, so again, both of these are land applications. The only difference was that we used the compost extract instead of the rejuvenate. And then the only other difference was that we did not perform a hard mow out there before we planted. And this photograph is Emily from that earlier photograph is spraying out this high fungal compost extract at site 2. And she's got a big tank out there on the back of a truck, and that pump is going. And then for the third site, for the third method, the bale grazing, we fed bales of hay out there. They got a new bale unroller with this grant. And we also fed humates and seeds. And we added a tiny bit of molasses to that mixture as well, just to get them interested. And the ratio that we did that at, and I'd be curious if other folks have tried this too, was approximately a pound of seed to 7 pounds of humate. And then, I think you can trial the amount of molasses that you add. You just want enough for them to be interested, and you don't want too much so that they're just eating it because it tastes good. Um, and then I went out and monitored at the end of July, the same as the other two sites. What's important to note here is that this, occurred between September 6th and October 2nd of 2024. So fall 2024. And and so it was a whole 9 months between when the treatment had occurred and when I had monitored, which is disparate and separate, distinct from these two other methods where, it was maybe only 3.5 months or so between the biological application and the monitoring that occurred in the summer. So just to keep that in context as we're looking at some of these results that are coming up. And this is what the area looked like after bale grazing. Andy, the owner, said that it looked a little rough. He felt it looked a little rough right after they had done it in the fall, so he was nervous about it, but you guys will see later on that things turned out just fine. So, what did I monitor when I was out there? We did have some preliminary sampling that had been done or historical sampling that had been done, but the only thing I'm showing you today is the comparison between the control and the treatment after the treatments had already been applied. And so that's in 2025, July. So I took forage samples out there for quality, nutrient content, and biomass. I took observations down for ground cover composition, for soil hardness and structure, for plant diversity. And then I also took soil samples for soil biological numbers and for soil nutrition. So I'm going to go over the methods now, or sorry, the results now of these three different methods. So our high level findings, this is the control on that irrigated pasture. And this is the treatment. And you can see, I think it's represented in these photos that there was some positive changes in the ground cover composition. So in the control, we had a 29% bare ground. The ground was covered well, how do we say? 29% of the ground was bare, and that reduced down to 21% bare ground in the treatment. And then the litter content in this control area went from 48% in the control down to 38% in the treatment area. So that litter is, being recycled into the system and potentially being allowing more space for those live plants to then, have access to light and start to take root and photosynthesize. So that was reflected here. So live plant cover in the control was only 23%. And then in the treatment, that increased to 40% live plant cover. And we had some positive increases in soil biological numbers as well. So when I'm going to tell you that these particular numbers increased by 20%, these are going to be relative this is the treatment relative to the control. So the way I calculated that, just so you know that, is the treatment value minus the control value divided by the control value. So everything is relative to what the control initially was. So and feel free to ask me about that later if that didn't make sense. But I'm just telling you that this is a percent difference. So microbial biomass went up by 20% in the treatment relative to the control. The fungal levels went up by 30%, and so did the saprophytes. And saprophytes, if you guys aren't familiar or don't recall, are those decomposers in the community that are responsible for breaking down organic matter, complex organic molecules into something that more secondary uh, microbes and other organisms can then take in and utilize secondarily. So that's what's going to be responsible for things like the litter breakdown. So that's what we want to see. We want to see these saprophytes increase. And then the second site, we have this control area over here and this treatment area over here. And a couple of things I noticed just from the images were that there were a few more um, bindweeds, which is a strangling vine out here. That's what these white little flowers are. And I thought I didn't have any numbers associated, but just visually, they seem to be more present in the control area compared to the treatment area. And those guys really like low organic matter conditions generally. And then this treatment area too, I'm not sure you can see from this photo, but there are these anthers that are poking out, these kind of yellow structures here in the grasses. And so these grasses are in full blossom and they're in full reproductive mode. And yet in this control area, I didn't hardly see any anthers present. So that was something that I thought was really interesting. And then I will say that there was a little extra compaction in the treatment area in localized areas where those tires had been and where those treatments had been applied. So that's something to note. But overall, the bare ground that was out there was not substantial to begin with. So the control only had 6% bare ground to begin with, and that reduced down to 4% in the treatment area. But the larger differences that we saw were these decreases in the litter that was out there. So in the control, we had 74% of the ground was covered in litter, whereas the treatment area had 46% of litter coverage. And um, that in addition to that, I think that really converted to more live plants being able to survive and thrive out there. So we had 19% coverage of live plants in the control relative to 49% live coverage in the treatment area. So I was pretty excited about these results. And then in addition to that, there was a 54% biomass increase in the grass that was out there, which was very visible once I put those grasses in the bag and got to see how much taller the grass was in the bag, the forage biomass bag that was in the treatment area than I took in the control. The third site was again the bale grazing site. That was the only site where I found that there was a plant species diversity increase potentially. And I will just say and point out a caveat that the control and the treatment were not directly next to each other. They were close to each other, but not side by side. And so if I did this again, I would really want to try and replicate this where there was more of a side by side comparison. So I'll just say that. And so I take that with a tiny bit of grain of salt. And I would just want to make sure if I did it again. We also saw some really positive ground cover transformations again. We had 18% bare ground in the control, went down to 10% in the treatment. For live plants, it was 34% coverage, and the control went up to 59%. And then for litter, that all of that brown content that was out there that just was not moving and not integrating back into the system um, diminished substantially. So in the control area, we had 48% litter on the soil surface, and in the treatment area, that went down to 31%. And that was reflected again with good biological increases here in total microbial biomass going up, fungi, and those saprophytes, those decomposers. And then in the forage biomass too, we had a 244% increase in that biomass, which was really impressive. And in addition, I think the most striking thing about these two images is just the color difference, right? So these in the control, these grass species are already browning out. They're not going to be very appealing to the cattle at this point in time. And in the treatment area, they're only just starting to blossom, a lot of these things, whereas this is already seeded out. So that means a lot when you're trying to graze and trying to extend your grazing days into the summer. And I'd be remiss if I didn't talk a little bit about poop here because we did feed some humates out there and we had really good consistency. This is that really perfect um, pie sort of they call it pumpkin pie sort of consistency of the cow patty that you want to be looking for. That's your ideal. And when I turned this cow patty over, there was this nice granular structure in there. I wasn't seeing like hardly any fibers in there at all, like you would usually see in most cow pies. And when I was also turning it over, I was seeing these little, maybe you can't tell what it is, but these little white strings, those are actually little seedlings that are growing up underneath the cow patties. And not only were they underneath the cow patties, which were holding all of this wonderful moisture, and there was a lot of aeration happening because of just the structure was so, it was like a sponge. It was very light. Um, but still like had some structure. And there were lots of insect holes in it, lots of earthworm castings like in it. It looked great. And then in the control, and also just to note, this was in the spring after. So grazing happened in fall. This was in spring. And then by the time summer came around, this is what the cow patties were looking like. They didn't really have any structure anymore and they were falling apart and they were really looking like they were reintegrating back into the system. Whereas this control, this is taken on the same day. These cow patties looked about the same as they did when they came out of the animal. And it's extremely dry in there. There's some, microbes and some other, well, sorry, some insects that had gone through the cow patty, but the consistency was completely different. And that's where that humate, if the forage is not that high quality, can really balance out and the digestion of the animal and create these nice superior patties. So I think that's really the strategic time to be using that. So these were some exciting results. And then just to sum it all up, I'm almost done here. And keeping in mind what our goals were at the beginning, which the first goal was to increase the forage productivity and the quality. And so our results really were fairly consistent for the productivity across all of these different methods. So, generally the living cover increased in every single one of these methods. And I could not get a biomass. I wasn't able to get a biomass sample for this particular trial because if you remember, we did a hard mow in the spring. And so it was not going to be a good comparison to compare treatment versus control. So I don't have a biomass number, but I'd love to get that this spring if I can, after the full growing season has happened and things can sort of re-regulate. In terms of quality, forage quality, what was interesting was that in both of these land applications, the quality went down, either like not very much or like a fair amount. So relative feed quality went down 12 points in this system in this first trial, and then it went down by 4 points in this trial. And that was enough to categorize it going from good in the control to down to fair in the treatment. And so got to think like, why is that happening? In those feed results, those carbohydrate and the lignin levels were elevated. And when you have plants that are getting taller generally or potentially more healthy, what I've seen in other results as well is that those plants will invest more into lignin content because they do need to get taller, they do need to be stronger, in winds and that sort of thing. So sometimes the relative feed quality can take a little bit of a hit, is what I've been seeing. And then in the grazing scenario, it was such a stark difference between the the growth phase of the forage out there that the relative feed quality went up by 44 points. And it went from utility in the control to fair, up to fair in the treatment area. For the second goal, that was plant diversity. Did we increase plant diversity? We did not in both of these methods, but again, we only had 3 months. And I think it's worth pointing out that those seeding treatments, even though we put a lot of nice products on there, they were still not effective. So at least we know that now. You don't know unless you try some of these things out. And then but the only place where a plant species diversity did increase was in the bale grazing area. Then for our third goal, did we improve soil microbial activity and levels? And I think across the board, pretty much yes. So we decreased the litter content and all of these trials in the treatment areas relative to the control. And we increased the biomass levels wherever I could take biomass. I was unable to get biomass in this location because I thought it would save time. Emily and I thought we would save time by taking just one sample instead of sampling separately because she had another project she was working on. And we didn't check that I sample it 4 inches deep for soil microbiology, and she was sampling it 6 inches deep, which makes for a comparison that is you can't compare. It makes a very big difference to those 2 inches for the soil microbiology. So that's another measurement that I would love to go back and sample for this season actually. And so yeah, we saw some really great increases in fungal levels and saprophytes in both these sites, and then here especially with the protozoa, which are those predators that help cycle nutrients and make sure those nutrients don't just get trapped in the microbes that are holding on to them. So making sure those nutrients can cycle and make it into the plants for forage health. So overall, what I take away from this is that all of these methods were pretty effective in improving a lot of aspects of the forage, and it was even more impressive how quickly that happened, especially with these two just land applications and, even this bale grazing. It was just not even one season had passed. And I think it's really just what are your goals that you have? Are livestock readily available? Do you want to actually put extra time into brewing or not brewing, but making a compost tea, or do you just want something to apply out there? What is your budget? And so that's another thing to bring up here. And I think people want to see that the only difference between method 1 and method 2, again, was that product, that Rejuvenate product versus the fungal link product. And that Rejuvenate was $46 per acre at the rate that we applied. And the fungal link was $9 per acre. So with the fish hydrolysate, or that fish fertilizer that we used, and the biological inoculant out there that we used, that came to $104 per acre. And then this second method came out to $67 per acre. And we initially wanted to be able to just isolate some of these products too, and just sample the fungal compost, the high fungal compost. And so that would be something that I'd like to do in the future because, I think that's just something that I'm interested in, to get that cost even lower and see what the potential benefits of that are. And then the bale grazing is a little bit different to be thinking about in terms of its cost, because you're actually getting a little bit of a benefit, right, out of the what you're doing on the landscape, because you're paying to feed an animal, and you're going to get the benefit of having fed that animal at the end of that animal's life cycle. And so you could just say, okay, it's $4,000 divided by an impact area of 25 acres. That comes out to $160 an acre. Or you could think of it as $4,000 fed 80 head of cattle for 26 days, and that came out to $1.92 per head per day. And that might make sense to do at a time when you need to feed cattle anyways, like in the winter or the late fall. So that's that's all I have for you. I have a few links that I can share with you in the chat, so you guys can reference some of these products that I was referring to, and also some of the other diagrams and things if you're interested. But otherwise, I'm happy to take any questions that you might have.
Right. We're getting quite a few questions coming through the chat. Thank you, Rebecca. I appreciate um, your perspective and how thorough you were in engaging us all. And so I'll start with the chat questions, and then we can raise hands if there are questions that have not been answered after that. So Nancy was wondering how rangeland and pasture quality is measured in the context. How does the USDA determine it? How do we know it's degrading? What measures are we looking at in that scenario? I think you're muted.
Thanks. Yeah, that's a good question. For that particular study, I think that they have a whole bunch of different things that they do. I've never done an assessment like that, but they are essentially trying to understand, is that pasture based on what they're looking at. So I'm sure that has something to do with um, what is um, the height of the pasture, what's the density of the pasture out there on the landscape that they're looking at. I'm not sure what tools they use for that, but what the answers that the questions they're trying to answer rather are, is this forage excessive to the number of animals that are assigned to this pasture or this area, in terms of the feed, like the amount of feed that's out there. What they're doing is they're trying to quantify the amount of feed that's out there, and how much that can support essentially. And
So
so is it excessive? And that would be
looking at
excellent.
kind of the production, a forage production from
Exactly.
on a large scale. Okay.
Exactly. Yeah. So there's different levels that they might determine that more specifically. But I can share that link to that paper, and you can check out more specifically what they did for that. So I'll put that in the chat for you.
So in determining what methodologies you were using and what drove the decision to go for a hard mow was it location two?
Um, it was partially location. So the decision to do a hard mow, that was like answering the question, can we get away with avoiding tilling the landscape? So with the goal being, increasing diversity out there by planting, And the tried and true method of doing that is to disturb it, till it, put annuals in, let them grow, terminate them, then plant your perennials that you want to establish, and then allow that to happen, for a few years. And that's sort of the standard practice for doing that. And the reason we wanted to mow was to see whether that helped reduce the competition between the annuals that were out there. They were fairly sparse here and there. There was a lot of bare ground, but we wanted to know if that was enough to set them back enough with all of the nutrition, all of the biologicals that we'd put on that seed treatment, that would have made those ideally, or the hypothesis was to make them really healthy so they could outcompete. So that was the reasoning behind doing that. Um,
That
and
kind of leads us to Jane's question is what was the species compositions at the sites prior to the treatment?
Yeah. So at the first site, we had predominantly annuals. So that would have been like brome, bindweed, pennycress, alfalfa, some quite a bit of lamb's quarter. There was some clover out there, and lamb's ear and some cheatgrass. That would have been the first site. And then the second site would be bindweed, salsify. This was the one with quite a bit. It was a fairly good established pasture, a good mixture of annuals and perennials. So bindweed, salsify, alfalfa, pennycress, mustard, some new smooth brome grass, western wheatgrass, and it did have some cheatgrass out there as well. And then on the third site, there was dry brome out there. There was dry rye that was in that control area for sure. There was cheatgrass, there was bindweed, alfalfa, salsify, and thistle.
All right. So, what biological tests did you utilize?
So I used the PLFA test for all of these. And that gives you various indicators. It gives you your bacterial numbers, your fungal numbers, your total microbial biomass numbers, as well as some stress indicators of the community. It was interesting that those stress levels it indicated that there were higher stress levels in some of those where we did the treatments. So there was disturbance happening there. And so I think that maybe potentially that was picked up in those numbers. But yeah, that was the PLFA was what we used.
And then here are folks asking for some distinctions on your second and third treatments. Did you use a compost tea or extract or compost broadcast as a whole? What was the process there at site two?
Yeah, so this was a compost extract. So we
Okay.
took 3 pounds of compost. This is a high fungal vermicast compost. And you take that and you leave it in water for approximately 30 minutes or so in a bag, that's maybe like a burlap bag or something that it can get through and seep out of. And and then you're ready to apply it then at that point. And that's the compost extract that we applied on the landscape. And it was 3 pounds in 10 gallons of water per acre.
Acre. Okay. So, do you know what type of hay was utilized in the bale grazing?
Um, no, I don't know what type of hay it was.
All right. Are there any more questions out here? Raise your hand if you want to jump in. I know I didn't get to all of them that came through in the chat, but I want to give folks the opportunity to ask for themselves or not if they may. I was wondering, do you feel like with the bale grazing treatment, were you seeing the seeds as a result of the manure or the in the area where the bale was as kind of a byproduct of the hay in that area more? What's your
Yeah,
observation?
that one's a hard one to track and to verify. What was causing that? What I can understand though for sure is that those patties and the consistency that they had because they had that nice structure that held onto some moisture, and created this nice environment that was conducive to making seeds germinate. So
Provided a
where
good
those seeds came
microclimate.
from, yeah, exactly. Where those seeds came from is another question. And it's hard to verify if it was what we fed out there either. And unless it was actually coming out of the patty itself, I don't think I would be able to say, oh, like that came from what we it would have been hard to
Just
identify whether
the
that came from
the
what we
exact
planted out
source.
there or what was already out there.
Craig, you have your hand raised. Are you able to unmute yourself?
I'll try. There we go.
There we go.
Yeah, I just had a question. Rebecca, on the first treatment, you did some seeding on that as you did the seed treat, and did you do that as a drill? Or was that you did that as a drill seeding, or how did you seed
Yes,
that?
it was drilled.
Was that mostly native seeds or native grasses or native plants you pleated into that, or?
It was a mixture of both. I think if we had more time, definitely, if we had more time for this particular grant, then I would have been interested in doing it the right way, I guess is what I'm trying to say, to establish um, plants out there. And because we didn't have that much time
Sure.
to actually establish a pasture in the tried and true method, I thought, you know what, I use these products in some of my cropping systems. I'm just curious if they might work at all. But yes, that's what we did.
Okay. Well, I was just thinking that you might, I know on some native seedings, it can take some time for those to show up. So you might actually see something this year that you didn't see last year. I mean, are you going to continue to monitor? I assume you're going to probably continue to monitor these sites and see if there's additional changes over time.
Yeah, it's a really good point, Craig. Yeah, this is only tested 3 months after some of these things, 3 months after the
Right.
application was performed. And so, yes, some of these things need like a full freeze thaw cycle and all the everything above. So, there's stuff in the seed bank now. So maybe if maybe it's possible, right? So it'd be
Okay.
exciting to be able to know that. And I wish it'd be wonderful to be able to get funding to continue these measurements in the future.
I think we have time for one more question if someone wants to jump in. Okay, Sydney, if you're able to unmute yourself.
Rebecca, I'm just curious if you or your clients were surprised at any of your findings.
Um, yeah, I mean, I think I'm always excited when something works. Um, not that things don't work, but it's just when you take an action and you see a difference, it's always very exciting. And I think they were most excited by the fact that their organization, their methodology is all livestock based. And to them, they thought that like the grazing experiments produced some of the most significant results. or most extreme results. And so they were quite satisfied with that. And they, I think, were energized by that to continue bale grazing. And now that they have this data, they felt like they could maybe help justify if they wanted to write more grants to get that done. Thanks for your questions, everyone.
Yeah, thank you all for taking the time out of your day to be here with us. We appreciate the thoughtful questions and your presence. So look forward to more of these in the future.
So wonderful to see all of your faces. Thank you so much.